Okay, so part 2 of our video, let's see what we're going to focus on now. Now we're going to talk about measures of central tendency. What that means is we're looking for the middle number of all of our data. Why is that important? Well, basically it's the average amount. The middle number is the average, which means it's something that's the most typical, the most common, the most normal. So there's 3 ways to find the measure of central tendency. It could be a mean, a median, or a mode. Let's talk about each one of those. On this slide, you just write down the definitions here. A mean is the typical average that you're used to calculating from old math classes. Basically, you add all the scores together and divide by the number of scores. The mode is another way you can find the average number, so to speak. It's the score that occurs most often. And the median is another way. You can find the median by taking all your information and putting in order from the smallest to the largest, and then finding the number that lands dead smack in the middle of the data. I'm going to do all 3 of those here. Alright, so example 2, copy down your directions and then number 1. Alright, well, for number 1, the first thing we're going to do is we're going to do the average. Now, what we're dealing with here is a stem and leaf plot. So what I really have is 81, right? And then another 81. And then an 82. A 75. A 72. 73. Now these are out of order. That shouldn't be, by the way. They should always be in a common descending order. So feel free to fix it in your notes. So basically I'm just unwrapping the stem and leaf plot. Now you don't have to do this if you don't want to. I'm just doing this for the sake of showing you where I'm getting the numbers from. So basically I'm going to add all these together and divide by how many there are to find the average. Okay, well, after I add all those numbers together, I get 754. So to find the average, or the mean, we would divide 754 by how many numbers there are, and there's 11 of them. And it turns out there's about 68.5 as an average there. So that's our mean. Alright, well, next let's go ahead and calculate the median. To find the median, you want to put your numbers in order from smallest to largest. Now usually a stem and leaf plot is already in order from smallest to largest, but this one's a little bit messed up. So I'm going to go ahead and redo that. So we have 82, 81, 81, 75, 73, 72, 67, 64, 56, 52, and 51. Okay, so we want to find the middle number. So what we do is basically just chop numbers off both ends until you get to the middle, right? That's one way you can do it. For really big data sets, basically just look how many there are, divide it in half, and find that middle number. But in this case, we'll just chop off until we get there. And the number you're left with at dead smack in the middle is your median. So that's how we'll find our median. The median is 72. Finally, we need to find the mode. Now that's the number that occurs most often. In a stem and leaf plot, this is really easy to see. You just look for the number that's repeated most in a row. As you can see, there's 2 81s. Nowhere is any number repeated. So the only number that's repeated is 81. So 81 is the mode. That's the number that occurs most often. Alright, there's a second example here provided, but this data is given to us in the form of a frequency distribution. So go ahead and copy down that slide, or this number 2. Alright, once again I'm going to, just for teaching purposes, decompose this into the raw data. What this is telling us is that we have 2 children that are age 2. So I'm going to write 2 twice. It tells us that we have 5 children age 3, so I'm going to write the age of 3 5 times. And then we have 2 children age 4. And then we have 3 children aged 5. And we're being asked to find the mean, median, and mode. So once again, we add all these numbers together and divide by how many there are. Well, for the mean, if I add together all those scores that I wrote at the top up there, I get 42. There's a total of 12 ages there. So if I divide all those numbers by 12, the sum of those numbers by 12, I'm getting about 3.5 for my mean. Now the median, once again, we're going to calculate that in a similar fashion. I think something interesting is going to happen this time though, and you'll see what it is. We'll just hack off until we get to the middle again, right? Hack. Now something happened here. This time we end up with 2 numbers. Now in this case they're the same, so it's pretty easy, but sometimes they're different. So what do you do if you end up with 2 numbers in the middle? The answer is you average them. So you take your 2 middle numbers, you add them together, and you divide by 2. Well, since they're the same, obviously it's going to come out just to be 3, right? Finally, we have the mode. The mode will be, of course, the number that occurs most often, and from a frequency distribution, it's kind of set up for that. Which one occurs most often? Well, the one with the highest number of students is this one. It's got 5 students. That's age 3. So the mode is 3. And that's how you calculate mean, median, and mode. Alright, so a final example for you guys to take a look at will be right here. Go ahead and find the mean, median, and mode of this data. Pause the video, take a few minutes to work on it, and then as soon as you turn it back on, you'll have your answer available to you. Alright, well here's our solutions. The mean was 18.875, the median was 18, the mode was 24. So why do we have 3 different ways to calculate the average or the middle number? Well, because sometimes one is better than the other. Now typically the mean is the best, not always, but usually, because it uses every number. You have to add every number in and divide by how many numbers there are. The median is helpful when there's a strange number and they're this really, really high or really, really low. So for example, if I gave you this set of information, what would you say the average is? Well, it's probably going to be close to 3, right? The middle. But now let's say I add one more number in there. Try the average and see what happens. It shoots way up because there's a weird number that's unlike all the others. These 4 are really close together, but that 20 is a really high number. Really high numbers or really low numbers are called outliers, and they can really mess up an average because the average incorporates all of the numbers, even that really high number. But with a median, it wouldn't affect it. It doesn't matter if this 20 was a 20 or if it was a 5, the middle number would still be 3. So medians ignore outliers, which is good if there are outliers. Finally, there's the mode. This is probably the most rarely used. It's used for what's called categorical data. That means data that has nothing to do with numbers. Like, for example, if we want to do a statistical survey on what's the most popular brand of clothing, well, you can't average, Tommy Hilfiger or something like that. That's not a number, it's a brand. So modes is just for counting how often a certain thing occurs. So that's for non-numerical data. And that concludes our lesson.